Okay, let me just give you a quick announcement here. We do have a few announcements today. For your quizzes number 5 and 6, I'll make sure you receive the feedback tomorrow so you can prepare for your exam using the quizzes. And for your lab test 3, what I would do is I'm going to grade them first, and then whoever actually got zeros for whatever reason, I'm going to ask the TA to look into your submission and try to see if there's anything we can do. So this might take a little bit longer than usual. So this is my tips for you. For the exam, don't wait for the result for the lab test 3 to come out. It might take longer because of the process I just described. But lab test 3 was only about the tutorial videos and practice tests, so you didn't lose anything without knowing the results. Okay, so you can still prepare. But for lab test 3, I will make sure it's available to you early next week. Okay, with the extra care I'm going to do for your submissions. Okay, the plan for today. I want to finish the last bits for the lecture, which is about how to use a hash table. I just want to visualize exactly how the hash table looks like, and then do a little bit more coding together. After that, I will wrap up the course, and then we'll talk about the exam at the end. Okay? It's only for those of you who attend the class today. No recording for that part. All right. Let's go back to the last bits for our course over here, which is about using Java API. Basically, let's think back why we are doing this lecture over here. After this course, you're supposed to be more experienced than how you were 2 months ago. You know how to do things from scratch by using if statements, loops, and also arrays. But now we would like to say if you want to become a more professional developer, let's say doing some part-time job in the summer, you always want to solve the problem not really completely from scratch. You want to rely on certain reliable solution that people have already developed. Java API is an excellent resource for you. Okay? So now we only talk about array list so far. So I will just talk about one more, okay? Which is hash table. The best way to understand a hash table is to think about this kind of mental picture. Okay, let me just recap very quickly. Okay, for the exam, for the array list and also hash table that we talk about, you don't have to know how to write the code using array list or hash table. You are only expected to read the code using hash table and array list. Okay, so now let's have a look at the hash table. Okay, you can think about hash table is just like a two-dimensional table with only 2 columns. The left column is simply called keys. You can think about key is really like an object for you to somehow identify certain row in the table. For example, using the key Alan, you can identify this particular row. Using the key Tom, you can identify this particular row, and etc. Okay, we're going to see some programming manipulation in just a moment. The second row is called values. So these are the main things you want to store in the table. The types for the value can be anything. It can be string, it can be integer, it can also be any kind of objects. In this case, we simply say the left column, the keys, will just be the names for the student. Let's say Alan, Mark, and Tom. And also for the values, it will be the letter grades they receive for certain course. You can see it's either A, B+, or C. Okay? So now there's something I want to emphasize over here about hash table. It's really crucial. So the keys will be no duplicates. You can see Alan, Mark, and Tom. Okay, you can see Alan, Mark, and Tom here. There's no duplicates over here, which means if you're given Alan, you know exactly this is the row you're talking about. If you're given Tom, it must be this row you're talking about. On the other hand, values may contain duplicates. So what do I mean? 2 students with different names, they might receive the same letter grades. For example, let's say Alan has gotten A. It could be that Tom also has gotten A as well. This is also allowed, which means with the same key, you might have more than one value that's associated with it. Sorry, with different keys. Let me say that again. Let me take it back. With different keys, let's say Alan and also Tom. They are different keys representing different rows, but the values over there can just be the same. That's okay. It's only that the keys must be unique. There cannot be any duplicates. Okay? That's all you have to know conceptually about what a hash table is. Yes? Okay, so what can be the type of the keys? As far as you have to know for this course, okay? Keys can typically be string, it can be integer, it can be any type actually. Okay? Basically for the keys it can be any type. So now the word hash over here has something to do with a process called hashing, which we wouldn't have to learn for this course. You'll only learn about it if you have to learn 2030 later. Okay? But you only have to know for the keys. Let's say for now you can assume if I give you the hash key, it will always be just a string. Okay? Or integer. In which case integer can just be 1, 2, 3, 4, all the unique numbers. Okay? Okay, that's about hash table conceptually. Let's have a quick look of the code. And that's the API. Again, for the API for hash table and array list, you don't need to memorize anything. Guys, I'm very sensitive to, voice. Very sensitive. Okay, so now for API, you don't need to memorize them. Okay, you will be given API, whatever that you actually need in the exam. Okay, but you're supposed to know how to read them. Let me recap very quickly. So for example, for each row in the API, first of all, you have the name of the method over here, also telling you how many parameters they might take. In this case, for the size, it simply takes nothing. On the other hand, for contains the key method, it simply takes one input over here. Okay, and then this is the return type for the method. You can see for the size, it's simply just going to return integer. But what exactly is the integer it is going to return? You have to read the summary description over here. It tells you return the number of keys in this particular hash table. For example, you can see the size for this particular table over here is simply Alan, Mark, and Tom. You got 3. Okay, so here you got the size would be 3. Let's see another one. You also got different Boolean accessor over here, which will return Boolean. It tells you whether a particular key value is in the table or a particular value is in the table. For example, if I ask you whether this particular table here contains Alan, indeed it is. Alan is over there. Does it contain A+? No, because A+ is not there. We only got A, B+, and C. Does it contain B+? Yes, it does contain, right? So this kind of the method call we can expect. Okay? And then we can also say, given a particular key, we want to return its associated value. For example, if you're given this key, let's say Mark over here, what's the associated value? B, B+ over here. If you're given Tom, for example, what's the associated value? It would be, in this case, A, but we just assume that's A. What if you're given a key, let's say Jeremy, in this case? Well, you can see that Jeremy is not contained as a key in this table here, so its associated value should be null. Okay, it's very easy, intuitive for you to see. Let's see some code over here. Okay, you can see the rest. You can also try to put a key value pair into the table. You can also try to remove a particular row associated with the key. Okay, we're going to see that. Let's now go to this particular code over here. Okay, it's also on your slides. Rather than showing you on the Eclipse, I'm going to make the source code available to you for your study. But let's just go over that. Only a few lines for us to trace. Okay. Specifically, I want to show you how you can visualize the table quickly. Let's look at the first line. The first line, we're simply declaring a hash table over here. Okay, so now you can see that over here, the first type over here is the key, which means every key is a string. The second one over here is a value. Every value is also a string. Let's say the name of the table is simply called grades. We're going to store letter grades for the students. And then we simply just create an empty hash table to begin with. So after the first line, what do we have? Basically, we have the grades, which is the variable name, is storing the address to a 2-dimensional table, as we said. Okay, so it's a 2-column table here, and then we have keys and we have values. At the moment, nothing has been stored, so the size of the table is simply just 0 at the moment, right? So now let's try that. So the next line, when we say grades, which is the table, that size, is going to give us 0. Nothing has been stored. Okay? What about when I say grades that contains key? I'm asking, look at the left column over here. Does Alan exist as a key? No. So that'll be false. And the next one, grades that contains value. I'm asking, look at the second column over here. Is B plus over there? No. Also F. Okay, easy. Initially, the hash table is simply just empty. But now, let's see how we can add key and value pair into the table. Okay, so now let's see the next line. So now, grades.put. Okay, that's a very important line. That's how you insert into the hash table. So we are saying that we're going to insert the following row into the table. The left column, the key should be Alan, and the right column value should be A. So that means after this line over here, we're going to put Alan and also letter grade A. After that, okay, easy. What about the next one? The next one is going to be, let's say, use green. Grades.put, mark and then B plus. So what I will do is I'll add another row over here, which is going to be mark and also B plus. Okay, so far the size has increased to 2. The next one. Okay, the next one, let me use pink, maybe orange. Grades.put, Tom and then with letter grade C. So what is it going to do? In this case, it's going to be Tom and then C. Okay, you can see after these 3 put statements, we basically have got a table of size 3, okay, with the 3 entries over here. Okay, any questions so far? Okay, so far it's very easy. So now I would like to just revisit all the accessors and see what the return value should be. Okay, the first one, what should be grades.size? 3. 1, 2, and 3. Okay, that should be 3. Grades that contains the key. Look at the first column. Look at this column here. Is Alan a key? Indeed, it is. So that should be true. Is Mark a key? Yes, it's over here, so that should also be true. Tom is a key, so that should also be true. So now the next one. What about contains key but Simon? Simon is not there, so that should be false. Okay, now similarly, if we try to call the contains value over here, we got A, B plus, C. Okay, you can see A, B plus, and C, they're all there. So every one of them will just be true. What about A plus over here? A plus is not there. Okay, so that should be false. Okay, that's how you can easily trace the table very easily. So now let's see another one. Let me highlight it. This one is very important. Let me use here. If you look at this one here, grades.get Alan. So what does that mean? That means I want to find a particular row that can be identified by the key Alan. Find that row and then return the value of that row. So now what I would do is over here, you can see Alan is representing this particular row over here, and then I want to return that particular value, which is A. So that means Alan has got letter grade A. So this will be just A. Okay, the next one, grades.get, and then I got Mark, right? So what about Mark? In that case, Mark will be this particular row, and then return B plus. Okay, you can see everything is very intuitive. Let's do one more. And then we get to the next one. What about grades.get Tom? Well, Tom is this particular row, that should be C. Okay, the next one. What about grades.get Simon? Well, in this case, Simon does not exist just yet as a key. In that case, you can see there's no such row that can be identified by Simon. In that case, it should just be null. Okay, if you execute the code, you're going to see exactly null. Okay, one more thing, 2 more things to show. Okay, this one here, we're saying grades.put, and then mark, and then F. So now, this is an interesting case. Think about what kind of a dilemma we're having. you can see we are trying to do the put again, but the key we are trying to put in, which is mark. But mark seems to be already existing in the table, right? So it doesn't really mean we're going to insert another row with a mark and F. What's wrong would be to thinking this way. This will be wrong. If you simply say, I got mark over here, and then I got F. This is not the case, okay? It is not. Because in that case, you will simply get duplicates of the key, which should never occur. What this would do instead is going to overwrite whatever letter grade that's associated with mark, okay? So now what this will do is it's going to see, okay, F, so go to this particular row, and now overwrite B plus into F. So that means after this line, mark's letter grade is going to become F. Okay, it's a very important case for you to remember. If you try to do the put, if the key already exists, that means you want to overwrite that particular row with a new value. If the key does not exist, add a new row. Okay? And then now if you say grade.get mark, so now mark is in this particular row and we have just overwritten that with F. So that should just be F. Okay, final operation to see. What about grade.remove? And then we give a key value, Allen. This one is also intuitive. That means I want to first of all identify the row with the key Allen, which is this row here. Okay, it's exactly this row over here. This row has the key Allen. And now when I say remove, that means completely remove that particular row. It will simply just wipe it out. Okay, you can think about conceptually, we wipe it out. So now how many rows do we have? Only two. Only 2 rows left. So now after this particular line, I'm going to say grades dot contains the key Allen. Allen has just been wiped out. So this would be false. Okay, and then if you say grades dot get Allen over here, because Allen does not exist anymore, so the associated grade should just be null. Okay, you can see it's quite a bit of code over here, but the operations here are intuitive. Okay? You just have to remember specifically for this case over here. When you are trying to put something for some existing key, it's not going to create a new row. You're just going to overwrite the existing row. Any questions? Are we okay? Good. That will be the last bits for the course. And now let me just do a very quick wrap up for you for what we have learned for this course, and then we'll talk about exam. Okay? Let's wrap up the course over here. I want to bring you back to this particular slides. This is almost the first slide I showed to you back in January, the first course. So why are we taking this course? I want you to think back what you have learned in the past 3 months and try to think about why things will actually make sense if you think about this original goal. So the purpose of this course is really about computational thinking, meaning that all the concepts you learn in this course, selection, loops, array, API, everything we learn, even the Eclipse, IDE, debugger, breakpoints, they will be transferable skills for you to use in any other language, like a C, Python, C#, or any other new language you have to learn in the future. Okay? So now I want you to know the following. It's really important for you as a programmer or engineer. You should always, first of all, know how to code. That's how we assess your coding skills in the lab test. But number 2, above the level of code, that's even more important. You want to be a logical person. You want to know why a particular fragment of code will work or not work. And that will be the focus for the exam. Okay, I will talk a little bit more about it. Which means I'm really trying to assess whether, given a fragment of code, can you really know what the output should be, or whether the code should work for whatever reason. Okay? Okay, and for those of you who might actually find some engineer job, for example in Google, over there in the interview, they actually try to test your logical skill by asking you to program on the whiteboard. You can actually have a look at the YouTube link to see how things go. Okay, just give you a little bit more perspective. Okay, so now let me just recap what you have learned in this course, and this can be a very good checklist when you review the exam. Okay, I will divide it into 3 different categories. You can think about what you learned before the reading week. Before the reading week, we didn't learn anything about objects. So it's so-called procedural programming, which means you simply just execute code line by line without too many methods, basically. We don't really talk about multiple classes or multiple methods, just a single main method executing from the beginning until the end. So we learned about primitive types, assignments, and casting and coercion. Make sure you review the difference between these two for numbers, right? For this part, don't worry, I'm going to post a slide for this part, okay? And also Boolean expression, logical operations, and short circuit evaluation, okay? It's a very important programming concept for you to remember. If statements, nested if statements, and also solving problems iteratively. So this is really when things can get complicated. You want to know about for loop, while loop, and how can you get to infinite loop, and how can you actually maybe run exactly this number of iterations, right? That's something we talk about as well. Also, we talk about one-dimensional array. It's a little bit pity I couldn't really finish two-dimensional arrays for you, but I'm going to give you some reference for those of you who might be interested in exploring that in the summer. Okay, the second part is about object-oriented programming. I would say that's really the critical part, which will combine procedural programming with the extra complication about objects. Okay, classes, attributes, objects, reference data types, right? There are two data types in Java, primitive type versus reference data type. And also we talk about three different kinds of methods. You can have constructor, you got accessors, you got mutators, and also you have some helper methods. So the helper methods, we don't really cover that in the lecture, but it's mentioned in the tutorial videos. If you go to the end of the classes and objects slides, I do have three or four examples over there to show you. They're self-contained, do learn from them. Okay, it's good for you as a programmer to use as many helper methods as you can. Also, we talk about the dot notation, context objects, and method calls. So these three are very important for you to trace the code if I give you. Okay, aliasing. Okay, remember what aliasing is. It's really important. Okay, and also we talk about Java API. So far we have used math, scanner, array list, and hash table. For the exam, you don't have to worry about scanner. Okay, it's only for you to complete your labs to make things a bit more interesting, so you can build console application. Okay, we also learned about different keywords. So these are just some examples. You want to review what final is, this, and also static. I would say this and static are particularly important. Okay. Finally, another category over here. There's something I forgot to list over here, which is GitHub. So the GitHub project management tool you learn in week number 1. I would say that's not really a required component for this course. I decided to introduce it just because it's how people actually manage their software projects in the industry. Okay? So if you later become a professional engineer for coding, try to use GitHub. At least we give you some introduction to this course. Hopefully many of you have been using GitHub for your labs. Then that's good for you. Okay, so now we talk about compile time versus runtime in the Eclipse, right? Okay, remember to review what the distinction is between these two. We talk about 3 kinds of error. I would say by now your code should contain very, very few syntax errors. Okay, as I said, once you get used to doing exercises, syntax errors should really go away very quickly. I believe many of you might still be struggling with type errors, so this will take even more experience. Basically, type errors means you cannot write any expression that don't make sense. Okay, just review what we said in the lecture and the tutorial videos. Number 3 is really the most critical error you might have, because they're usually not obvious. If you have any syntax or type errors, your program just cannot be run. End of story. But if you got logical errors, your programs can still be run, but its behavior is weird. Okay? So now, logical errors is actually, even for experienced programmers, they can still make such a mistake. For you, just be aware. You should always be logical. That's why there's a best way to prevent logical errors. Also, we talk about creating console application. We have done quite a lot, on the weekly exercises. And also how you can, just build out console application. Now, I want to highlight really the meat for this category about breakpoints and debugger. I'm actually quite happy many of you during the lab test were trying to debug your program using breakpoints and debugger. That's really nice. So debugger and breakpoints are universal ideas across any programming language. If you program Python or program Visual Studio for C#, they do have the same concept for breakpoints and debugger. So once you learn about how to do things in this course, you can definitely use them. And also for Android Studio, If you want to program some mobile app, they also have debugger and breakpoints. The same idea, okay? Okay, right. Beyond this course, let me just give you a little bit more references if you want to explore further. Number one, for Java tutorials, I will keep all the tutorial videos on the web. Let me just show you once more, so in case you forgot about the links. Let me just show you the web page quickly. Sorry, it's a little bit slow. Okay, so that's the tutorial videos we have gone through. I'll give you a little bit more tips to have more focused study for the exam. But these videos, I would say I'll keep them there. If you need to review Java, feel free, okay? They'll be there. And also, we got, for two-dimensional arrays, I really hope that I could cover that, but we just didn't have time. I'd rather not rush the things. So for two-dimensional array, it will not be covering the exam. However, two-dimensional array is a very nice extension to one-dimensional array, especially you really exercise your techniques of using nested loop, okay? I'll just point you to one of my courses last year. If you click on the link, you will go to my, If you click on the link, you will actually get to 1022, the parallel course in the CS section. So it's last winter, it's pretty new. If you go towards the end, I did talk about two-dimensional arrays over here. It's about two or three lectures over there. It's self-contained. Okay, you can just follow them and then do some exercises over there. Okay, it's a good challenge. Finally, if you really want to pick up more advanced Java skills, for those of you who will take 2030 either in the summer or in the fall, you don't need to worry too much about this, right? You will just take the course anyway. But for those of you in mechanical engineering, civil engineering, if you really want to pick up further Java skills, you can feel free to go to my lectures page for 2030, just back in the fall last year. If you go there, similar style, you can see I got all the resources over there. It basically is assume what you have learned in 1021, and then pick up from there and talk about advanced stuff, especially inheritance, which is a very interesting topic. Okay? If you want to do some more self-study in the summer, that can be one resource that you can consider. Okay. Okay, so for those of you who will take 2030 in the fall or in the summer, remember 1021 is something they will assume you know already. So do review the stuff, not just for the exam, but for the next course. Otherwise, if you don't take any further programming courses, just keep the skills since you spend time. Okay, just don't abandon Java. Don't abandon Java in the break. Any questions for me? Okay, I think that'll be it. Let me just finish the recording over here.